Hello students, myself Dr. Anupreeta Mishra and you are watching Anupreeta Mishra's Electrical Engineering channel. Here I am discussing synchronous machine, why we are calling it synchronous machine. Similarly, I have discussed in my Hindi version of videos about the name given to induction machine, why it is in the word attached to it is induction. In the same manner, I am discussing why the synchronous word is being attached. The reason behind this is that in synchronous machine, either motor or generator, rotor revolutionary speed is always same as that of the revolving magnetic field's speed. Means rotor is rotating by some speed, say n or ns, so the revolving magnetic field produced in armature side or stator side is rotating with the same speed. So there is a synchronization between the speeds of two rotors rotational speed and revolving magnetic fields speed, both are same, hence the name given to it is synchronous machine. But why such thing happens there, why it happens, I am giving you the reason behind it. Synchronous machine is a doubly excited machine actually, and in case of synchronous machine, if I ask how it is being doubly excited, so there are two electrical power given to the synchronous motor, one from the rotor side and another from the stator side. I am rubbing it because what should be the direction of the current fed from the supply side of three-phase armature? That would be this one. Here I have the three-phase supply fed to the armature winding over the stator, and here I have the DC excitation fed to the field winding placed over the rotor. And because of the interaction of these two electrical powers, two fluxes, torque generates and rotor starts to rotate, and we have the rotation of the shaft, and hence load, mechanical load which is being attached to it gets rotated. This way two excitations are given, hence we call it doubly excited. In case of synchronous generator or alternator, how it is doubly excited? In that case, the direction of the current is outside because we are taking out electrical power from the armature winding. So a load, three-phase load is being connected to it. We feed mechanical power to the rotor and we rotate it with some speed, say n speed. We try to rotate it with the help of turbine, and the speed given by turbine to the rotor is n, which is 120 f by p actually. I'll discuss it here also. And rotor DC field winding is being fed by the DC excitation. So two excitations are there. One is DC electrical excitation and another is the mechanical power fed to the rotor to rotate it simultaneously with the help of turbine. So two powers are given, one is electrical power, another is mechanical power, and with the interaction of this electrical and mechanical power, here electrical energy generates and get fed to the outside to the three-phase electrical load. So this way motor, synchronous motor and synchronous generator, that is alternator, are doubly excited. They are known as doubly excited. Now if we want to rotate this, I am explaining, let me tell you, I am explaining this answer, how this happens, why rotor speed and the revolving magnetic field developed by the three-phase armature winding are of same speed. The reason being what exists over here, that answer I will be giving you with respect to the synchronous generator, because till now I have discussed, I have taught you only synchronous generator. Whenever I will be taking up the synchronous motors topic, there also I will give you the answer like this with respect to motor itself. Synchronous generator, as I said, doubly excited, rotor is being fed by the turbine to rotate it with some speed 120 f by p. So that speed is this one, and I have already taught you the derivation of this formula. What is here? N is nothing but the speed by which we are rotating the rotor. P is the number of poles given over the synchronous machine, either 2 pole, 4 pole, 6 pole, 8 pole. But in India, we have been restricted with the frequency 50 hertz. What does this mean? If we give the speed n number of poles are P over the rotor. So the frequency of the EMF induced in this armature winding would be of F, and we have been constrained with 50 hertz, so we need to generate here EMF of 50 hertz, we need to generate here or induce here the current of 50 hertz. So that means this F is fixed for us 50 hertz. Outside India it is fixed for 60 hertz. So this frequency is 50 hertz in India. So by keeping this, in order to have this 50 hertz frequency to be induced with the EMF and current in armature winding, we must rotate the rotor of two pole machine by 3000 rpm, so that here the power is of 50 hertz. If we have four pole machine, then the rotational speed given by the turbine to the rotor must be 1500 rpm. If machine is of 6 poles, to have 50 hertz electrical power here, induced power to here, we must rotate the rotor by 1000 rpm. Similarly, 8 pole machine has to be rotated by 750 rpm. What is happening here? I am giving the rotational speed. Say I am picking up this example. I am rotating the rotor by 3000 rpm. Machine is of 2 pole. This particular rotor field, DC field winding is rotating, so the flux produced by it is rotating. That rotating flux is cutting these armature windings. These armature windings are having the EMF induced in them according to Faraday's law. That EMF would be of this frequency F, that means 50 hertz, what we want to keep here. 50 hertz supply. So 50 hertz current is being flowing through this. That 50 hertz current is producing its own three balanced fluxes of 50 hertz variation. AC fluxes are there. Those three AC fluxes all together generating a single revolving magnetic field of 1.55 m. Its derivation I have already explained during my induction motors teaching. So the current which is being flowing through these three phases of 50 hertz, it would be producing three fluxes, balanced three fluxes of 50 hertz, and those three balanced fluxes are going to produce one single revolving magnetic field whose magnitude would be 1.55 m. That would be the magnitude of one resultant revolving magnetic field, and that revolving magnetic field again be rotating proportional to the current's frequency which is here, and that current's frequency is 50 hertz. So the revolving magnetic field's speed will be 120 into 50 upon P if it is 2, as I took the example of 2 poles. So again I would be having a synchronous speed 3000, by which I have rotated the rotor, and whatever revolving magnetic field is being produced, that is again of 3000. So the rotor's revolutionary speed and synchronous speed of the revolving magnetic field both are same. This is the reason why there is a synchronous link between the rotor's rotational speed and the revolving magnetic field of the armature winding or stator field. Hence, there is a synchronization of rotation of rotor which is being provided by the turbine and automatically induced revolving magnetic field in the stator. Those two are of the same speed, like here 3000. So those two are synchronized. This way I have explained why the name given to synchronous machine as the synchronous, why the synchronous word is being attached to it, because there is a synchronous link between the rotor of synchronous machines rotating with the same speed as the stator rotating field is rotating, that way. Now I am giving you further explanation of singly excited and doubly excited. As I said, synchronous machine is doubly excited, but induction motor is singly excited, because in induction motor, this is three-phase induction motor's electrical circuitry representation. In induction motor, we feed it by three-phase supply through the stator. Only one supply is given, no other electrical supply nor mechanical supply is given to it. So when one three-phase supply is given to the stator winding, three-phase winding, revolving magnetic field produces. This revolving magnetic field itself is rotating, but rotor never catches the speed of revolving magnetic field. Its speed never being ns. It is always less than that. So reason behind this is that one single supply is given to it. Because of that single supply, revolving magnetic field is getting power to rotate, and part of that power is received by the rotor to rotate. The difference between the two powers, the power of the revolving magnetic field and the power received by the rotor, there is a difference between the two powers. So rotor rotates by the lesser speed, not with the same speed, and where that difference of power goes, that is part of losses actually. This way we can explain that singly excited induction motor, in singly excited induction motor, rotor never catches the speed of revolving magnetic field. Its speed is always less than the revolving magnetic field. If anyhow somehow if I feed the rotor by some mechanical power, then I can match up the speed of the rotor with that of the revolving magnetic field speed of revolving magnetic field of the stator in three-phase induction motor. So when I give double excitation, then only the speed of rotor can be matched with the speed of revolving magnetic field. So this is the reason behind in synchronous machine, that doubly excitation provides or keeps the synchronous link between the rotor's speed, synchronous speed, or rotor's rotating speed with that of the synchronous speed of the armature's revolving magnetic field. Hoping that you people are understanding my last explanation also about the doubly excited and singly excited. If you don't understand, please let me know. I'll take up this topic as a separate one. And same sort of logic I apply over when in transformer, if primary side is being fed by some AC power, secondary side is also being fed by the AC power, then there would be addition of the two fluxes produced due to primary power and produced due to the secondary power. There would be the addition of power. And if only one side supply is there, no, and second one is the utilizer, then the second side will develop a flux which would be opposing the primary side's flux. Whatever I am telling you, please go through the playlist of dot convention in Hindi version, so that you can understand what I am telling you right now better. So hoping that you have understood the reason behind why synchronous word is being attached with the synchronous machine. This is also the answer of question why synchronous machine always rotates with a constant speed. Synchronous motor is rotating with the constant speed. This is again the reason, but I will transform it with respect to the synchronous motor's perspective. Here I explained it with the perspective of synchronous generator. Answer is same beta, but the little bit I would be having the different explanation for this. But this is true that rotor is rotating with the synchronous speed and revolving magnetic field of the armature is rotating with the synchronous speed. Both are synchronized with the same speed. Hoping that you understood each and every concept delivered by me today. So please do like my videos, try to subscribe my channel, try to suggestions to your friends also to subscribe my channel, and go deeper and deeper into the concepts of electrical engineering with the help of my knowledge sharing. Thank you.